Okay, let's start. So in the previous class, we have seen missing values imputation, and in that we have seen mean median concept, right? How to fill the missing values. Okay, if it is numerical missing values, how to fill it with mean median. Okay, today we are going to see the next step, that is how to fill with some random value. Okay, so if I go over here, yeah, so this is my toy data set. Okay, and the first thing we need to do before filling the missing values is we need to see whether the data set has some missing values or not. Okay, now these are the missing. And so when you do this df.isNull.mean, okay, so it is showing that age is having an average of 19 missing values. Okay, and fair is having 5. Okay, and then this is your x, this is your y. Okay, and this is your train test split. These are the common steps. And once you do that, okay, next thing is, as I said, the way how you can fill missing values is by two ways. One is pandas, okay, and the other thing is sklearn. Okay, in sklearn you are going to use simple imputer. Okay, in pandas you simply use fill na. Okay, that's it. Just like how you use drop by drop na, you're going to fill by fill na. Okay, so now as you can see, you are using the fill na. Okay, in previous class you have used mean or median, but here you can use some, this is example showing some random value. Okay, so age I'm filling with 99. Okay, or some other random value -1. Okay, and this is a constant value, and I'm going to fill all the missing values using this value only. Okay, and for example, you're going to fill fair with 999. Okay, and this is with -1. Right, so how you can choose this value? So it's completely random, there is no logic behind it. Okay, so instead of filling with mean or median, fine, so if you cannot decide, let's say if even mean and median are also not suitable, if you feel after checking those three things like distributions and outliers and correlations, fine, so if both mean and median are not working, so you can try using some random value, completely random value. Okay, and after that the same steps. Okay, so you need to check the variance. Okay, over here as you can see, using variance, when you fill it with 99, the variance is very much high, okay, when compared to the original. Okay, but when I use with -1, it is okay, it's not very close, but comparable 304, it is okay. Okay, and also when you see, when you are filling with fair, when you're filling with 999, the variance is extremely different. Okay, obviously as expected. And when you're filling with -1, we're having some 2378. Fine, and after that you can do some graphs. Fine, and this blue color is the original part. Okay, and red is 999, sorry, 99, and green is -1. Okay, both this 99 and -1 are all, both are very different from the original graph. Okay, but if you want to pick one, you can pick from the variance part, you can pick some 19, sorry, which one, -1. Okay, and after that you can see for the fair, these are the distributions. Okay, and these are the correlations. Because I've covered this in the mean median chapter, so I'm not going into detail. Fine, so then you can see the correlations part, fine, covariance part. Okay, and based upon this you can take a decision. And the same thing you can do using the sklearn also. In sklearn you have direct function simple imputer. Okay, over here your strategy is constant. Fine, earlier your strategy used to be mean or median, remember. So but now we are filling with a constant value. Okay, so now the strategy is just constant. Okay, and one imputer is for 99 and one imputer is for 999. Okay, and this is imputer 1, this is imputer 2. So you are using imputer 1 on age column, and you're using imputer 2 on fair column, and remaining columns you are passing as it is. That's why you need to use pass through. Okay, that's it. So after that, we are fitting this transformer on your extrain data, and it will show you what all imputers it is having inside it. Okay, and this is a imputer for the first one 99, and this is imputer for the second one 999. Fine, so you're fitting on the train data, and same thing, you're fitting, transforming both on the train data and test data. And now, as I said, this will give you a array. Okay, ND array. Fine. And this is your extrain, and you can use this extrain directly for the model building. Fine. So now this is the basic way how you can fill the missing values, and it is though you think there are many steps, the main step is over here, the fill any. What value you are going to give over here in the fill any is the one thing. Now what random value you need to use is completely your wish. Okay, you can try pick and choose with different random values, because it is the word itself is random, so there is no logic behind it. Okay, so this is actually one way, but as I said, there is no logic behind it, and the variance is not in our control, so this is not usually recommended. Fine. I have rarely used this, or also seen people using it rarely. Okay, so mostly you can go with the mean or median. Okay, or the other techniques which we are going to study in future. Fine, but this is how you can do it in pandas, and this is how you can do it in the sklearn. Is it clear?
Yes, sir.
Okay. So apart from this, I also said that you can also use something called as end of the distribution. Okay. So over here, theoretically, I will give you, because the notebook will be exactly the same. So the end of the distribution is, so you know the distributions, right? So over there you will have the lower bound and upper bound. Okay, you are going to have lower bound and upper bound. Okay. In some cases, if you don't want to use this completely random values, okay, you can also use the lower bound and upper bound values. Okay, from where you are going to get it from the IQR, interquartile range, right? So using the interquartile range, okay, for any given distribution, you can find out Q1, Q2, Q3, etc. Okay, and using that you can find out this lower bound and upper bound. Okay, so in some cases, instead of these random values, okay, you can also use lower bound or upper bound values. Okay, so that will be doing it via end of the distribution. Okay, but whatever the method you are going to pick and choose, finally you need to check few things, how the distribution is after the imputation and before the imputation. Okay, and other things like what do we have the out, whether it is introducing any outliers, or whether it is the variance is much different or not within the previous one, and the covariance correlation, what all things we have seen. Okay, but out of these three, mean and median are the most common. Okay, and your first go-to option should also be mean and median whenever you're dealing with the numerical things. Okay, numerical variables. Fine. So now coming to categorical data. Okay, so over here it will be in the form of categories. Okay, as a simple example, it will be like in the sex, male and female. Okay, so obviously here you cannot do mean or median. Fine. So the one thing which you can use is the most frequently occurring value, that is called as mode. What is mode? Most frequently occurring value. Okay, so here you are having two things. Okay? So one is mode, and also one more technique is just something called as missing. Okay, that we are going to see. First, let's see what is this mode. Okay, so over here, yeah, so let me take this example. Okay, so in this example you're having only three columns. Okay, fireplace, garage, quality and sale price. Okay, and now when you see the missing values, okay, so this is my count. Okay, fireplace and garage are having, actual fireplace is having decent number of missing values, and garage is having quite a few missing values. Okay, and now this is my df.garage.value counts. Okay, in this garage itself there are different categories. Obviously, as you can see, in the first place all these are categorical values. Okay, this is also category, this is also category. Okay, now the categories inside this garage, okay, are these ta, fa, gd, po, ex. Okay, what are these categories? We don't know, but these are the five categories which this garage column is made up of. Okay, and now, what is the mode? When you do garage df.garage.mode, obviously it's going to give you to the mode. Okay, and from the this diagram also you can see that TA is obviously the mode, because its count is way high when compared to other. Okay, and obviously that's why the mode is TA. Okay, fine. So and after that, when you see you are plotting two graphs, guys. Okay, so one is df of garage whenever it is equal to TA. Why TA? Because mode is TA. Okay, when my garage value is equal to TA, okay, what is the sale price? And when my garage is having null values, what is the sale price? Okay, so houses with TA is a blue color and houses with NA is my red color. Okay, houses with TA is blue color. This is a sale price when the value is TA, and this is a sale price when the value is null. Okay, because it can also have null values also, right? Because as you can see, garage is having 5% of null values. So wherever the value of garage equal to null, still there will be some sale price. Okay, that values this red color is showing. Okay, this is a red color where the garage values are null, and blue color is where the garage values are TA. Okay, fine. So after that, this is what where the garage value equal to TA and what is the sale price. Okay, sale price that we are taking into temp. Now df of garage dot fill any. Okay, now fill any is how you are going to fill the missing values using pandas. Okay, and I'm filling with what mode? TA is my mode, right? So that is done. Okay, and once you fill it with mode, I mean, now when you see the bar plot again, obviously if you observe, earlier this is a category and there are also something called as NS. Okay, now what, now TA is my mode. Now what we are doing, we are filling all these NAs with TA. Okay, now this will also become TA. Now obviously that will furthermore increase the value of this TA. That means it will still a bit higher. Okay, this range will furthermore increase from 1200. Simple. That's why if you can see, it crossed from 1200 to almost 1400. Why? Because the NAs are also now filled with TA over here, as you can see, fill NA TA. Okay, now we are filling with TA because TA is the mode. Okay, fine. And after that, now you can see the distribution. Okay, now the distribution is not making much changes. Okay, before and original. Okay, this blue color is original and red color is a imputed variable. Okay, so before and after, you're not able to see much difference, which means that okay, it is okay to fill with the what, with the mode. Okay, fine. And now coming to fireplace. Okay, now coming to fireplace, here if you see the value counts, okay, now these are the value counts. Okay, and obviously from the visualization also you can see GD is my mode. Okay, now when you do the mode also, GD is my mode. Fine. Over here also same thing. So here what we have seen in garage. So first we have understood what are the missing values percentage. Okay, after that, since it's a categorical value, we are trying to see the value counts, and these are my value counts. TA, obviously TA is my mode, and you have seen the distribution. Okay, when it is having the mode value, which is TA, and when it is having null value. Okay, and post that we have filled it with the TA. Okay, once you have filled it with TA, you have all again check the distribution. Same thing you are going to follow with the fireplace also. So my mode is GD. Okay, obviously as you can see, this is GD, and this is my distribution. Wherever the GD is having, wherever the fireplace is having GD, and wherever the fireplace is having null. Okay, and next thing is obviously we are going to fill it with what? We are going to fill it with GD. Okay, GD is the mode, and once you fill it, you are going to see the value counts again. And same thing you can expect. Earlier the value GD value count is around 350 or 400. Okay, once you fill all the null values with GD, okay, once you fill everything with GD, obviously it will spike. Okay, as you can see, it is going till 1000, much higher. Why? Because the fireplace is having maximum missing values. All these 47% of the values are now filled with GD. Okay, are now filled with GD. So that's why you can see a higher increase in the value. Okay, 1000. And after that, you can see the distribution before and after. Okay, so these are not exactly the same. Fine, these are not exactly the same, but because, and also you can also observe logically, if if you speak, what we are filling with the mode. Okay, and in any given distribution, okay, so not any distribution, in a normal distribution, this will be the mode, right? Why? Because this is having the maximum frequency. The x will be some, the x-axis will be a certain value and y-axis will be usually frequency. Okay, and where you are having the maximum frequency at the peak. Okay, we are having the maximum frequency at this value at the peak, and that is also called the mode. Mode is what? The value which is occurring most frequently. That is mode. Okay, this is mode. Now, what we are doing in our case, we are filling the missing values with mode. Fine. So obviously, that mode value, whatever you are having, that is going to increase. So in the distribution also, wherever you are having mode, that is going to give a spike. Okay, because the mode is this one, and after that it will become this one, because more values are now replaced with mode. Getting? So here, why here we are not able to see much difference is it here with just 5%. Okay, only 5% of the values are filled with the mode. So that's why you are able to see just a slight difference. Okay, but here 47% of the values are filled. That's why original value is blue color over here, and if at all this peak is the mode, and red color now on this blue color distribution, wherever you are having null values, all those values are now filled with, okay, all those values are now filled with what? Mode values. Okay, so that's why this mode now after imputation, that red color one, wherever you are having mode, that gets peaked, that gets peaked. Agree?
Yes, sir.
Okay, so now that's the reason these two are different. Okay, so that means wherever you are having maximum null values, if you are having maximum null values, so the distribution will also change maximum. The distribution will also change maximum. Okay, why? Because obviously you are, if you are using mode to fill all the null values, the mode will not be the same as earlier. This will become this. Okay, fine. So now this is using pandas. Okay, the same thing you can also achieve using sklearn, as I said. Okay, now sklearn or train test split. Okay, now what you are going to do, you are doing train test split, etc. And simple imputer. Okay, the only thing you need to make sure is here strategy is most frequent. Okay, so you might observe that in sklearn is more easier, because if it is mean, you're using mean. If it is median, you're using median. Here it is mode, but you're not saying mode. Okay, what you're saying, I'm saying most frequent value. Take the most frequent value. That's it. Take this imputer, fit on X train, and also fit on X train Y test. Okay, X test Y test. Okay, and this is your statistics. Okay, now here it is saying for the first column the mode is GD, and for second column the mode is TA. Okay, what is my first column in the data set? Fireplace. Okay, in fireplace, what is my mode? GD. Okay, and in second column garage, it is TA. Okay, so that's what it is saying over here. Okay, so GD and TA are my two modes. Okay, for implementation wise, I would say sklearn is very, very easy. It takes less lines of code. Clear?
Yes, sir. Clear.
Okay, fine. And now this is what we have seen just now. Okay, in categorical, how to fill it with mode. Okay, very simple. I don't think any difficulty to do or understand, right? So just the only thing is, see this, as I said, all these types of distributions I'm showing you for knowledge purpose, and also recommend you to do. Okay, but if it is like general data set or a known data set, okay, you can use it, you can directly go with fill any. Okay, if you don't want to do all the three, you can at least check the distributions. Okay, fine. But the core point is how you're filling with the NA values, that is just fill NA, and over here just simple imputer mostly. Okay, fine. Second thing is you are in using the for the categorical values itself, you have something called as it uses, instead of using the mode value, okay, there is another method, okay, where they just fill with the word called as missing. Okay, just like in numerical how you are having some random value, okay, here also instead of using the most frequent value, fine, they are using with the something called as missing. Okay, and this is just a method I have not seen most of the time using. Okay, but since we are studying, okay, we need to study every method. Okay, so the same thing follows over here. Okay, so everything is same. Okay, garage we are having the mode value. Okay, but here you're not going by the mode. Okay, instead of that, earlier you have filled with earlier you have filled using uh, what earlier you have filled using TA, that is a mode, right? But here you are going to fill it with just something called as missing, the word missing. Okay, this is a string. Okay, and you are filling it by missing. Okay, so that's why if these are the categories before before, and you'll also have a new category called as missing. Okay, after filling. Okay, you are introducing a new category. Fine, so that the system will understand, okay, it is a missing category. Okay, and that's it. Okay, it's a small data set, and this is how you can do it using what pandas. And the same thing, if you want to do, you are going to fill, as I said, this is a constant. Okay, just like how you have filled, okay, just like how you have filled a at normal arbitrary value in the in today's, in the first few minutes we have seen how you can fill some constant value like 99. Okay, strategy constant, right, for the numerical value. Similarly here also you can use some constant, strategy as constant, but a value is just missing. Okay, so it is going to fill it with a missing value, introduce a new category. Okay, but this is just one more method, but most recommended value method is mode. Okay, is that clear?
Yes, sir. Clear.
Okay, fine. So now apart from this, there is also one more method, okay, that is called as random sample imputation. Okay, now what is this random sample imputation is here, because this random, here we have seen this random value. Okay, but here what is this random value? This is completely random value. What is this? That means you can take nine. I took 99, 999. Okay, you can take some 89, 78, something, or completely logicless random imputation. Okay, but instead of doing that, okay, now here in this random sample imputation, the idea is to take a random value, but not completely random. It is from the already existing values. Okay, that means if you are having, okay, if you're having age, okay, and as an example, if you're having 100 values, okay, in that 10 values, okay, 10 values are missing. Okay, now for these 10 values, instead of filling completely random values like I just said some thousand, etc., etc., obviously you cannot fill with thousand. Okay, now let's say maximum age is 100 or 90. Instead of filling some 55, 84, it is more useful. Okay, it is also more logical to fill these 10 values from the values which are already existing. Okay, 90 values are already present, right? So you can pick and choose at random 10 values from this 90 values. Okay, so that what is going to happen, you are not being completely random. Okay, you are already, you are making sure that this, there is a chance, okay, for this value to exist in reality. Okay, that means for example, um, there are 90 value, there are 90 values available, right, and 10 values are missing. So if I take this 10 values, okay, if I take at randomly 10 values as some, okay, one value as 9, okay, one value as 55, okay, one value as 64, okay, this is at random. Now, okay, these are valid ages only. Okay, these are valid ages only. Okay, but I am not sure whether this particular data set which I am working upon, okay, whether these values are, could be possible or not. I'm not sure if a person with age 9 is present for this data set or not. I'm not sure whether a 55 and a person with age 55 is present in this data set or not. I don't know. if I completely fill with random, because I have not seen this missing values, right? That's why it's called missing values. Okay, instead of doing completely random, but if I pick and choose from these already existing values, okay, so what all could be, see, I'm just taking as an example, so some random values could be, okay, so these could be some existing values. Okay, these could be some existing values which are already present. Okay, how many 90 values are already present? Okay, these are 90 values. Okay, instead of completely taking at random these 10 values, if I take from these, okay, I will say one out of this 10 random values, okay, one could be some 17, okay, one could be some 78, etc., and so on. Okay, now what I'm doing, so I am taking these values because I'm convinced that this age, there is a high chance that this age could be possible, could exist in the data set, because there is 117, there is also chance that there could be one more 17. Okay, because there is some 88, there could be one more 88. Okay, so this is also random, this is also random, but this random is from existing data, this random is completely different data. I don't know, there could be a possibility that 9 might not be there at all in the complete, or at all ages we are taking this 90 values, there could be no 9. Okay, so that means what? There is no person who is having age 9 in this data set, my data set. So if I randomly fill with 9, so obviously it will, the model will work, you will get accuracy, but it is not closer to the reality. Getting, it's not closer to the reality because I'm filling with some value which is not practically existing for this data set. Okay, so instead of doing that, okay, instead of doing that, if I take a random value from the existing values, okay, still at random, okay, but from the existing values only I'm taking, so it is giving us chance to be more closer to the reality when compared to the other method. Okay, is the logic clear?
Yes, sir.
Clear, right? Right, so that is this way. Okay, so you will pick it from the already existing values. Okay, so that is this. And also see, in categorical it is more easy to understand, because let's say you are having a category called as sex, and you are having male and female. Okay, now if you are having a big list of male, female, okay, etc., etc., and if you're having, let's say, 5 missing values, so obviously we will not fill these 5 missing values with some X or S or some T or M. Agree? It is more logical to fill these 5 missing values with either M or F. Okay, either M or F, obviously, because these are only the two categories that are present. It makes much sense to fill the missing 5 values also with either M or F. Similarly, for numerical values also, instead of filling completely with random, you are going to pick and choose from the existing values itself. Okay, I think this categorical example will be more easier to understand. Getting right this part?
Yes, sir. Understood.
Okay, so now regarding that, we are going to see example. Okay, now in the it's a simple example. Fine, so you are having age, fair, and survive. Okay, and this is how you check the missing values. Okay, now train test split, my survived, obviously this is whether survived or not, so that is going to be my output variable. Okay, now that is my x, sorry, that is survived is my y, and remaining everything is my x. Fine, so this is my train test split, x and y. Fine, this is x train, all these are common steps. Now x train of age, okay, x train of age is my age imputed. Okay, so now this code, just be focused. Okay, this needs a bit of attention over here to understand this one line of code. Okay, it's simple, but it is a bit lengthy, that's it. Okay, see how I see this particular code. Okay, how I am going to fill the missing values. See guys, what we are doing here, x train of age imputed. Okay, we'll go step by step. I am feeling the idea is just see there are two things. See, if anything you do, okay, there will be two things. One is theoretical, okay, one is the practical part, obviously, right? So now theory is the idea. Now my idea is to fill with random value, but from the existing value. Okay, random value, but from existing value. That means what you need to pick from the existing values, but at random. That's the idea. Now practical is the actual code, how we are doing it. Okay, that we are going to see. See here. Now, what we are going to fill, you are going to fill the missing values in the age column. Okay. Now, first of all, what is this age imputed? My age imputed is coming from here. That is my xtrain of age. What is this xtrain of age? You got this xtrain from the train test split. From here, you are having two columns, age and fair. In this xtrain of age, okay, I am taking it as age imputed. Okay, same column. Okay, I did not do anything here. Age only I am creating again as age of imputed. So that's why if you see age and age imputed, okay, these two are exactly same. Okay, these two are exactly same columns. Okay, why? Because I don't want to impute on this original age column. So that's why I created one more column, age imputed. Now on this age imputed, I'm going to impute the values. Okay, so that my age will remain as it is. Okay, because if something, if I do some mistake on this, if I directly do it on age column, and if there is some mistake, I will lose the original data set. Okay, again I need to input. Okay, to avoid that, I'm creating a, let's say, a copy of this age called as age impute. Okay, and I will do all my processing on this, and once I'm success over here, I can simply drop this age column. Okay, so that I will have imputed column itself. Okay, that's the idea. Fine. So now I have created a age imputed from this age column. Okay. Now on this age imputed, I'm going to do some imputations. What I'm going to do, see, you see, age imputed, that means x of age imputed. What is this is null? Okay. Age imputed dot is null values. Okay. That means null values from this age imputed, the null values you are going to take. You are filling with it with what this is actual code, this unit. If you understand this, you will understand everything. Okay, we are filling with what you are filling with xtrain age drop na. Okay, and dot sample of values. Okay, see here, you will go step by step. Obviously, see, first of all, the idea is you are having age column. Okay, in that you are going to take the only existing columns or existing values. That means you are dropping the null values. Okay, you're dropping the null values and taking the existing values, and in that existing values at randomly you are picking the values and filling where you're filling the null values itself. Okay, this should be clear. See, I'm repeating again. From this age column, you are having some values, and let's say this dashes are your null values. Okay, from this age column, first of all, you are dropping this null values. That means you're not considering this null values. Okay, or shall I put it as into? Okay, see all this, or 1 second. Okay, okay, all these tick marks are you're having some values. Okay, all these into marks are having some null values. Okay, so now the idea is from this age column. Okay, the idea is to fill these null values so with the remaining existing values. To do that, what you need to do, first of all, you should take only the values that are existing. That means first of all, you need to drop these null values so that you collect only the existing values. Okay, from that existing values, you are going to randomly take values and fill these null values. Is a idea clear, or shall I repeat?
Clear, sir.
Okay, so same thing, whatever I've just said, same thing we are doing in code. First, what we are doing, see here, xtrain dot age dot drop na. That means you are just dropping all the na values. If you drop all the na values, What values you will get? Existing values. Agree? If you drop all the till here, till this part, just this part, first part, okay, drop NA will give you just the existing values. That means non-null values. From that, you are taking a sample. Okay, you are taking sample and sample, and this part we will see what is this sample of some values you are taking. Okay, sample of some values you are taking. How many values you are going to take? How many null values are there? Those many values you are taking. Okay. First of all, we'll try to see what is this drop NA is going to give and the sample is going to give. Okay. This, see here. Okay. Extend drop NA. Okay. Drop NA will give you what? It is not having any null values. Okay. It will give all the non-null values. Okay. From this, you need to take sample of, say for example, if I say sample of 2 means it will give 2 values. Okay. Sample of 1 means it will give 1 value. Okay. Sample of 10 means it will give 10 values. Getting? From the drop in, from the existing values, non-null values, you can take a sample of any number of values you want to take. Okay. So I am taking sample of this many values. What are these? How many values I need actually? As many as my null values. Okay. How many null values does my, see how many null values, how many x's are there? That means how many null values are there? Those many samples I want to take, so that you can fill all the null values with the samples. Agree?
Yes, sir.
Okay. So that's why how many samples I'm taking? Extrain dot age, from age column, how many null values are there? Dot sum. It will give you the count. Sum, it will give you the count. Agree? So this one, if you see, okay, this one, if you see 148. Total, there are 148 missing values are there in the extrain. Okay. Total, there are 148 missing values are there in the extrain. Okay. Or here also, if you do df.external.sum, okay, age once, okay, let me run this again in the from the first place. Okay, it is having sum is 177. Let me run it from the top. Oh, from the training data, right? Okay, because the that's what I'm thinking. Okay, here it is, I'm doing it on the total data frame that is having 177, but here we are doing it only on the training data, right? Extrain. Okay, extrain. So here we have divided into extrain. Okay, now if you do extrain, okay, over here, if you do extrain dot is null dot sum. Okay, see here in my extrain, total 148 age null values are there. Okay, so these many sample values I want to create. Okay, so total 148 null values are there. So in the place of the sample, if I give this one in place of this number 5, that means that now this 5 will become 148. Agree? So it will generate 148 sample random values from this existing values. Agree? And all those values I am going to fill it over here. I'm going to fill it over here. Okay. So if I now we understood this part, see, this is broken into 2 parts. Okay. One is just what is this drop NA dot sample. Okay. Or see, extrain of age dot drop NA is one part. And in that, what sample we are going to take is the second part. Okay. So extrain of age dot drop NA is obviously it will drop the NA values and it will take the non-NA values. Inside that sample, how many sample you are going to take? You are going to take as many null values. That how you are going to get? You are just saying extrain of age dot sum. This is my total null values count. Okay, that value if you give it over here, okay, this you have to go give it over here. That means it will drop the NA values, and from the existing values, it is going to take these many random values. So 148 random values it is going to give you. Okay, so now if I execute this whole thing, okay, see, these are my 148 random values. Okay, there may be obviously repetition. Sample, it might, there might be duplicates. See, 21, 21, 54, and do we have any other 54? Around 6 or 39, 39. Okay, like that. There will be duplicates. Okay, but overall, it is going to create 148 values count it has given you. But the point here is these are all not completely random. These are from the already existing values from the age. Agree? Getting the point? So from the existing values of age only, you have considered 148 randomly values. Clear?
Yes, sir.
So now this one, sorry, now this one is this. Okay, you got 148 random values you got. Okay, now where you are going to fill, you are going to fill over here. So this age imputed is a column we have just created as a duplicate column. Okay, and in that what is this? This is null. Okay, you are taking wherever it is having null values. Okay, wherever you are taking null values. Okay, see extreme dot null values. See, see wherever you're having this true is null is true, right? So all those will be 148 values. Okay, all those will be 148 values. Obviously, in this is just a copy of this, right? The age impaired is just a copy of this age. Okay, so it will have overall 148 null values. Okay, and this 148 null values you are filling with this array. Okay, this 148 rows will be filled over here. Okay, so it might seem big, okay, but it is we have did nothing. Okay, we are just considered, we are just said from age imputed, you are saying all these null values should be filled with what? Should be filled from these random values. So we are getting random values. We are first dropping the values so that we'll get the non-NA values, and from that I'm taking a sample of x number of values. What is this x number of values? This is the count of these values. Okay, these values are total 148. So I'm just taking, giving the count in different way. Okay, I don't know how many values. I'm just taking is null dot sum. So this value will be 148. Okay, so those values will be randomly created, and those will be filled over here. Okay, so that's why it's called random sample imputation, but it's not completely random. Okay, so every value you see over here, there is a chance that it will also occur in the original data set. Okay, because why? Because I've already seen from existing only I'm taking, I'm not creating it. Same thing for the X test also, I'm doing the same thing. Okay, same thing. And after that, okay, this is what this is which I've just shown. Okay, and yeah, so once you have done this, so every value is now filled, because if you see this age is the actual column, but this is the age imputed. Okay, if you remember, if you see, we have done the imputation on the age imputed column, not on the original age column. The original age column will be same as it is. Okay, that's why you can see still NaN values over here. Okay, but now these NaN values are filled with some existing value. Okay, 33, say 16, 48. Okay, so now these are not completely random, right? So this 33, 16, 48 will already present from somewhere in this what, from this existing values. Okay, fine. So once you do that, so you can see the histograms. Okay, so see, it is almost similar. Okay, and this is also expected. Okay, why? Because logically, if you see, let's say this is some distribution. Now what we are doing, wherever you are having null values, you are filling with already existing values. That means there will be just like, okay, for example, see, try to understand this part. This is the original distribution. Okay, now wherever there is missing values, you are adding with already existing value. That means what? For example, earlier this value, let's say I don't know what is this value, I'm taking it as 30. Fine. Now 30, now this y-axis is what? Y-axis is frequency. That means the count. Let's say it is repeating 10 times. Now wherever missing values are there, randomly you are filling with some value, and that means you will use 30 also somewhere to fill the missing value. So let's say out of 200 missing values, okay, you are using 30 some 20 times to fill. So this 10 will increase slightly to more number. Okay, so this will become slightly like this. Like that, every other number will have a slight increase in their count. Why? Because they have used now to fill the missing values. They have used now to fill the missing values. This is actually important. Okay, I will repeat this. Okay, this is a very important point. See here. So what I'm trying to say over here is, let's say there are two examples. Okay, first thing is you're having a distribution like this. Now, if you are trying to fill it with mode, what's going to happen? Let's say it is having 1,000 values, in that 100 values are missing. Okay, if you are going to fill all the NA with this mode, okay, all these 100 values with this mode, what will happen? That means only this mode is increasing. Agree? Only this mode will increase. That means what? Earlier, if the graph is like this, after imputation, this will become like this. Why? Because what all NA 100 NA values are there, now all of those became mode, because you have used mode to fill the values. So this only this mode, what is the peak value, that will increase furthermore. Agree till this point?
Yes, sir.
But now instead of doing that, now what we have done in the random part, okay, if the distribution is like this, okay, the original distribution is like this, instead of using only one single value called as mode, what we have done, we have randomly used different values. Okay, I'm not using only mode, randomly I'm using different values. Same example, if you're having 100 and let's say 100 NA values, okay, out of this 100 NA values, I'm not using only single mode value to fill all the 100, because it might result in some spike of here. I'm using random. That means 100 NA values means what? 900 existing values are there. In this 100 values, I'm using randomly some values from this 900. So I'm not giving importance to any one single value, which might unnecessarily increase the spike. Okay, even if you use, instead of using mode, even if you use any random value, let's say some 999, okay, it will create some spike in some other place, because all NA values you are using only one value to fill in this scenario. But here randomly I'm using different values. Getting the idea? So here if you see, it is not just one value, it is just 148 values at random. I agree there are some duplicate. Let's say 21 is repeated 3 times, 4 times, but it is very small when compared to, because the burden is taking it's distributed across all other values instead of only one value. Okay, so you are bringing 148 values. Okay, you are getting the idea, right? So instead of, let's say mode is, for example, for this data set, let's say mode is some 50. Okay, now there are 148 missing values. Instead of filling 148 values with just 50, which will increase the mode spike, here you are using 148 different values. Even if not 148 different values, let's say some 70 different values you are using if there are duplicates. Fine. So the share is distributed. Fine. There will not be any unnecessary spike in the distribution. Okay. Same thing over here. So instead of using only one value to fill, so I am taking random 100 values from this 900 values. Okay. That means as I said, some 30 might be taken, some 10 times, and some number 55 might be taken some 6 times, etc. Like that 100 values I'm taking, so not 100 values, some X number of values I'm taking and repeating 100 times. Okay. So what happens, let's say this value is 30. Okay. 30. Okay. Now after imputation, what will happen? Earlier, if the 30 is present, let's say if 30 is present, let's say some 20 times. Okay. Now you are using 30 to fill missing values. Okay, but you are not using 30 for all the 100 values. You are using just for 10 values. Okay, that means what? Earlier, if it is there repeating 20 times, now it is repeating for 30 times. Okay, now wherever you are having 30, okay, earlier if it is like this, okay, now it will be just a small hike, but not this much. Okay, earlier if 30 is here, it will be just here. Okay, like that every value will be taking small share. Okay, if some value is, let's say, I don't know what value, let's say some 45, earlier if it is repeating X number of times, now it is just repeating a few number more. Okay, so there will be slight change. Okay, so that's why the distribution might be slightly different from the earlier, but it will be almost same. Why? We have distributed the share across different numbers randomly. Are you getting
Yes, sir.
clear, right?
Clear.
Fine. So that's why this is more suitable. As you can see from the distribution wise also, it is very much understandable. Fine. So why the graph is looking like this? Why there is no peak? Because I did not use mode. Okay. The blue color is original one. The blue color is original one. The orange one is slightly different. Why? Wherever you are seeing the difference, that means that particular value is used to fill the missing value. Okay. For example, see here. In this part, there is exactly no difference. Agree? The blue color and the red color, sorry, the blue and orange are exactly on the same. That means there is no difference. That means whatever the value that is falling over here, what value it could be, some, I'm not sure, but it could be something around 39. Okay. That means 39 is not used to fill the missing value. Agree? Randomly, it did not pick 39. Okay. The sample value is also random, right? It is not this sample what you're using here. It is just completely at random. Okay. So that means what? Whatever the value that is falling over here, that value is not used for filling any missing value. Why? Because if it is used, there will be slight difference. Okay. There will be a slight difference over here because the count will be slightly changed. Okay. For example, if you see over here, the blue color is down and the orange color is up. That means what? There is a very slight difference. Okay, that means there are some values used to fill the missing values. So that's why the new value is different from the other value. Okay, same thing for here and same thing for here. Okay, but overall, if you see, you can say almost no change. Fine, the original is almost equal to imputed, and you can with much confidence you can use this method because it is not creating much difference in the distribution. So if it is not creating much difference in the distribution, the variance will also be not much difference, and every other related value like correlation and outliers, everything will be not much different from the original value. Okay, so that's why if you see, yeah, even, yeah, as I said, even if you see the variance, okay, earlier it is 204 and now it is 199. Okay, very slight. Okay, almost considerable. Fine. And covariance also. Okay, covariance also, if you see, so earlier, yeah, so on the age part we have done, right? So for the age part, if you see, um fair and fair, okay, age with the fair is 71, and age with the age imputed with the fair is 55. Okay, 71, 55. Okay, slight change. Agree. And age with the, okay, there are only two columns. Okay, now what is this imputed? Age with the age imputed. Okay, you should not see age with age imputed. You should see only age with fair and age imputed with fair. Fine. And outliers decent. Okay, there is not much difference. Okay, see here, earlier also these many. Okay, now also this. Okay, not much difference in the outliers. Okay, there are not much difference in the outliers. Okay, so now after that, what you're going to do? Uh, you're dropping with one value. Okay, so yeah, so this is regarding the what is this, imputing with completely, not completely random value, but from the existing value. Okay, and the same thing we have done it from another example also. Okay, for the categorical value. Okay, for categorical value also, let's say we're having fire and garage. Okay, so here also you're checking x test, y test, etc., but the main point is here. Okay, so how you are filling with the completely random values. Okay, I hope this part is clear. Okay, so you're dropping, taking from the existing values, and as many number of null values you are filling it. Okay, here you're doing for the garage train, garage test, fire train, fire test. Agree? And that's it. And these are the values imputed. Okay, so as you can see, this is before imputed. Okay, and this is after imputed, and the values are not much different. Okay, so these are different categories. Okay, so I'll share this notebook, you can compare. As you can see, the values are not much different. Okay, and yeah, that's all I would say. But I hope the idea is clear for the completely random imputation. Okay, as I mentioned over here, so the point here is to not to fill completely random, but to fill from the existing values. Okay, so that the distributions and everything will not be much different. Okay, is it clear?
Yes, sir. Clear.
Okay, fine. So I would say that's regarding different imputations. Okay, we have seen for numerical how to fill with median, random value. Okay, for categorical mode missing, and also combined to both numerical and categorical, there is one more method that is called as random imputation, which we have just seen. Okay, and in next class, I will try to, for multivariate, as I said, I will try to show an example of K-NN imputer. Okay, iterative imputer, there's, we have also iterative, but this is very rarely used. Okay, so I'll be covering K-NN imputer, and post that I'll show you a data set with different examples, how you can fill the missing values. Okay, so this is regarding the theory and studying part. Okay, once we're done with the overall learning of missing values, so we'll see one data example, so where you will have all the concepts which you have studied will be covered. Okay, and that should conclude the missing value part, and post that yeah, we'll see what all we can cover. Okay, are we good?
Yes, sir.
Okay, thanks, take care, bye.